This is Goddess of Science Physics, and I'm Mrs. Bolvin. And this is the fourth part of our Newton's First Law series. And today we're finally get there. We're going to talk about Newton's Law of Inertia. Okay, so there's Newton, British scientist, all kind of awkward, incredibly brilliant. He had like an illness, for a little while, and he invented calculus to help explain some concept that he wanted to explain. So he was pretty big deal back then, but also very socially awkward. Would do some kind of crazy stuff, like if he didn't really like to go to social gatherings, and he didn't want people to talk directly to him. So if somebody wanted to have a conversation with him, they had to like not look at him and like be back to, like, if they had to be on one side of a shrub and he was on the other side. And if he got bored, instead of excusing himself, he would just walk away and leave the person standing there talking to him. So Newton, his first law of motion states that every object continues in a state of rest or at a uniform speed in a straight line unless acted on by a non-zero net force. That's a lot. We'll go through it, take it apart piece by piece. It's actually, the idea is a little simpler than this, but this is kind of like a big umbrella law that kind of covers both things at rest and things in motion. So, Newton's first law, usually called the law of inertia, and guess what? He kind of stole it a little bit. He restated Galileo's idea that a force isn't needed to keep an object moving. So he ripped off old Galileo a little bit, but what was Galileo going to do? He was dead by the time Newton came along. So objects at rest. Newton said, simply put, objects tend to keep doing what they're already doing. If it's sitting still, it's going to keep sitting still unless something acts on it. So objects at rest tend to remain at rest. If you set a glass of Diet Dr. Pepper down and no force is acting on it, it's still going to be there when you come back and get it. It doesn't get up and move by itself. Only a force is going to change the state of rest. You have to apply a force to get something to move if it's not already moving. So here's a famous trick that all magicians like to do, but it actually isn't really magic. It's more physics than magic. Oftentimes, magicians will put a whole bunch of expensive dishes on a table that has a tablecloth on top of the table, and then they'll pull that tablecloth out from underneath there, and the dishes wiggle a little bit, but they stay on the table. And the reason for that is Newton's first law. Objects at rest tend to remain at rest. The objects on the table have inertia. They want to stay there. So, interesting. So, an object in motion. Now consider an object in motion. Object in motion, any force acting on a moving object will move it in a straight line indefinitely. Whoa. As long as there's no friction. So in outer space, if you throw a ball, it will keep going in a straight line with the same velocity as you threw it with until it runs into something or a force acts on it. So toss an object from the space station located in the vacuum of outer space. Now, we're not talking about a Hoover in outer space. No, we're talking about a space where there is no air. That's the vacuum of outer space. And the object will move forever due to inertia because there is no friction to stop it. So objects continue to move by themselves if no forces act on them. So you don't need a force to keep an object going. That was Galileo's big thing. Need forces to overcome friction. Excuse me, it sets the object in motion. You set the object in motion initially, and if there's some friction, you have to continue to apply some additional force. Once an object's moving in a force-free environment, and that's really important, it moves in a straight line forever. When you are riding your bike, takes a little bit of force to get it going. You start pedaling and you go. But um, why do you have to keep pedaling? Well, we don't live in a force-free environment. You have a little bit of friction between the tires and the ground, so you have to pedal to continuously overcome that friction to keep yourself moving forward. That's it for this time. Thanks for joining me. Have a great day.